Hello, prob stats, and welcome to 8.4. This is the last section here. This is identical to the other two, except now instead of a proportion or a mean, we're going to do a standard deviation. So make sure you got stat disk open, and let's go. Like I just said, it's a hypothesis testing, but again, instead, it's going to be a claim about a mean. This is going to be about a standard deviation. That's typed wrong. So let's put this here. Let's put standard deviation. I'll have to fix that for next year, huh? All right, you're going to be test your claim about sigma or sigma squared, all right, or your standard deviation or variance. When you go through, we have your sample size, we have your standard deviation, we have your population standard deviation, your sample variance, and your population variance. Those have not changed for notation. The requirements, we need a simple random sample again. The difference here is this has to be normally distributed, and it is strict. Not normally distributed, you cannot do. All right, our test statistic for chi-squared is n-1, so like your degrees of freedom, times your s-squared over your variance. Okay, we're going to do p-values. We're going to find those from stat disk again. Remember, your degrees of freedom are always n-1. Your critical values again will be from stat disk, again with degrees of freedom of n-1. When you're going through testing claims about standard deviation or variance, the p-value method, the critical value method, and the confidence interval will all give you equivalent answers. So if one rejects the null, they all reject the null. If one does not, then they all do not. They give you the same result, which is very nice. Okay, chi-squareds are non-negative. They're not symmetrical. When we look through here, your chi-squared is almost always skewed to the right. The more degrees of freedom, the closer it gets to your normal distribution. All right, we're going to do an example here. We're going to use the p-value method this time. Okay, do supermodels' height vary less than normal people? So we have the heights in centimeters. We're going to do a 0.01 significance level. We're going to let our standard deviation is less than 7.5, what it is for a normal population. Okay, does this appear to change for supermodels? This is the question we're asking. Does it vary less than? So we have our supermodel data. You need to type this into stat disk. So pause and do that. All right, is it a simple random sample? We're going to assume yes, since we don't truly know. We're going to check for normality. So when you type this in, you should have done your data assessment. So when we looked at our normal assessment, Reiner Joyner, critical values, failed to reject normality with a 0.05 significance level. Failed to reject normality with a 0.01 significance level. So since we're failing to reject its normal, we get to assume it is normal and we get to move on. We look at our curves here. This is pretty close to a bell, and this is pretty close to a straight line. Neither one or bad. Okay, stat disk. We did the normal assessment. We explored our data. So for descriptive statistics, and we got our information. So you have to do that because we need the standard deviation. So our standard deviation from stat disk was 1.8439. Now we want to check our hypothesis testing. So we're going to go analysis hypothesis testing. This time it's a standard deviation for one sample. Make sure you are in the correct spot. Okay, we've already got our data checked in, and I hope you've written it all down. So we need to enter our stats. First, we're going to enter our, well, let's check, see if we remember. Our null hypothesis was that it equaled, or it was the same. And then our alternative hypothesis is that it is less. So our null was that our standard deviation was equal to the 7, if I remember correctly. Oh, 7.5. Our alternative hypothesis was that it is less than the 7.5. Okay, so we plugged in less than the claim. We want a 0.01 significance level. 7.5 is what I'm claiming it is. We have a sample size of 16. That does the n-1 for us. Our standard sample deviation from stat disk was 1.84391. hit evaluate. Now, when you do this, we get a test statistic of 0.907 and a p-value is less than 0.0001. Well, if the p-value is less than 0.001, is less than 0.01, then we have to reject the null. Since we're rejecting the null, that means our alternative is true. So we have sufficient evidence to support that supermodel's height vary less than the normal population of 7.5. All right, let's see if we can write this all out formally now. Remember, we got to follow our 8 steps. Step 1, what's our claim? We should have written less than 7.5. Okay, step 2, what's the opposite? So it's going to be greater than or equal to 7.5. Look at the equal, and this gives us our null, and this is the claim that we want, our alternative. So our standard deviation equals 7.5, or it is less than 7.5. Significance level of 0.01. Since it's about standard deviation, we have to use the chi-square distribution. When we do stat disk, we get a test statistic of 0.907 and a p-value of 0.001. I use the p-value this time. It is less than the 0.01, so we reject the null. This means there's sufficient evidence to support the claim that female models have heights with a standard deviation that is less than 7.5 centimeters. All right, that is about all we need. So now, the critical value method I wanted to show you. When you look at stat disk, so you're on stat disk underneath your data, you had a test statistic of 0.907. So 0.907 was right here. Our critical value is 5.229. It could be anywhere. I could have put it higher if I wanted, which is here. So when we look here, this is our rejection region. Since our test statistic falls in our rejection region, we reject the null, which is exactly what we said above. Just another method of getting there. You will have to do both, so make sure you get good at those. Last one was the confidence interval. So I'm looking at standard deviation. So we go here. So I am 98% confident, because remember it's a two-tailed test with chi. So I'm 98% confident that my standard deviation for supermodels falls between 1.29 to 3.1, which is quite a bit different than it is for a normal population. So again, it is less than 7.5. All right, it is your turn. So pause and try yours. Make sure you use our survey heights. Okay, I hope you followed all 8 steps. First, our claim was that our standard deviation was greater than 3. So the opposite would be less than or equal to 3, making our null standard deviation equals 3 and our alternative greater than 3. So we're a right-tailed test this time. Our significance level was 0.05. We're dealing with standard deviation, so we're doing a chi-squared test. Okay, when we plug this into stat disk, our test statistic for chi-squared was 32.9. Our critical value was 36.4. Our p-value was 0.105, and our confidence interval was at 90% between 2.85 and 4.6. Now let's look what these mean. This one here is the test statistic and the critical value. So when we look here, here's our test, here's our critical. Our test statistic is not in the rejection region, so we fail to reject the null. Critical value method. P-value method, 0.10505 is greater than 0.05. Again, we fail to reject the null. Same results. Confidence interval, 3 is within our interval. So again, we fail to reject the null. All 3 should give you the same result. Okay, what does this mean? There is not sufficient evidence to suggest that the heights vary by more than 3 inches. And we're done. All right, you have homework. Pick 2 problems that you like from 5 to 18. Make sure you go into stat disk following all 8 procedures and get those done. I hope you do well. The next one here will be your summative project. Excuse me. on page 409 and 413, make sure you are doing all 8 steps and make sure you're making sure your requirements are met. That will be for tomorrow.